When vMotion was initially introduced, all vMotions had to have been done between ESXi hosts that were managed by the same vCenter server. But as time went on, and with the release of vSphere 6, we enabled cross vCenter vMotions. That is, I can migrate a virtual machine that is running on a host managed by one vCenter to a host that is managed by another vCenter. This is a really great feature because it allows us to do things like long distance vMotion, across data centers, balancing workloads. It allows us to do things like disaster avoidance. So I can move my virtual machines from one data center to another data center, even when those data centers are managed by separate vCenter servers. Okay? So this is an important thing for us to be able to do, and certainly with the improvements that continue to occur in vSphere, this is one of the features that we got. So there are some requirements for cross vCenter vMotion. Now, this was introduced with ESXi 6.0. Now, 6.0 currently is end of life. So hopefully you have 6.0 and anything earlier than that removed from your environment. But if not, that's okay. You'll get there. Okay? But cross vCenter vMotion requires all of your source and destination hosts, as well as your source and destination vCenter server, to be at least vSphere 6. Your vCenter servers must be linked together in an enhanced linked mode. That is, your vSphere client has to be able to see both vCenters in the inventory in order to choose the destination vCenter server and then host or cluster on the remote side. Also, the hosts across the vCenters must be time synchronized. That's another important component for this. From there, we're going to have a network that connects the two vCenters and the two hosts. Now, this could be a wide area network, this could be a local area network, but we must have at least 250 megabits of bandwidth between the source and the destination hosts. Now, there are a couple of network checks that are going to occur before the migration takes place. The first thing that we're going to look at is MAC address compatibility between the source host and the destination host. What does this mean? Well, when your ESXi hosts are managed by vCenter and you create a new virtual machine or you power on a virtual machine, vCenter makes note of the MAC addresses of all of the virtual NICs, and it keeps those MAC addresses in a blacklist so that no new virtual machines or no new virtual NICs are created within that infrastructure that might cause a MAC address conflict. That's done on a per vCenter basis. So you can imagine an environment where I have two vCenters with virtual machines that might have the same MAC addresses. And if those networks are separated, that's fine. But if I then try to migrate a virtual machine into an environment that already has that MAC address in use, I'm going to have a problem. So during this network check, what the destination vCenter will do is it will look at the MAC address of the incoming virtual machine and virtual NIC, and if the MAC address matches the blacklist, it will change that MAC address as it comes into the new environment. Okay, great. We will also enable or allow vMotion migrations from distributed switches to standard switches and from distributed switches of different versions. With each new major release of ESXi, we have some improvements on the distributed switch, and we label those with a particular version of ESXi that they were designed for. And you can move VMs from a newer distributed switch version to an older one, or an older one to a newer one, all as a part of this network check process through cross vCenter vMotion. Now, in order to enable this technology, one of the things that we had to do was dedicate some separate CPU resources to the TCP/IP stack where vMotion VM kernel ports are going to be stored. So with the release of vSphere 6, we enabled separate TCP/IP stacks in each ESXi host for different types of operations. Prior to vSphere 6, all of the networking happened with a single stack in ESXi. And now, by having multiple stacks, we can separate a few things. We can dedicate separate CPU resources, we can dedicate separate ARP tables and memory heaps, and we can even create, with each new VM kernel port, a separate default gateway, which will allow us to do layer 3 long-distance migrations. So at the TCP/IP level on each ESXi host, we have a default TCP/IP stack. When we create a VM kernel port for vMotion, it will allow us the option of creating a separate TCP/IP stack. We simply say yes. Okay, we do that on each of our ESXi hosts, and that will allow us to separate the default gateway, have a new default gateway, and so on. We also can create separate TCP/IP stacks for provisioning, that is, cloning operations and things like that. And we can also create custom TCP/IP stacks if third-party vendors that are doing networking within ESXi choose to do that as well. So you can now imagine an ESXi host with multiple sets of TCP/IP stacks where they each have their own separate memory heap, have their own separate ARP and routing tables, as well as their own separate default gateways. And this allows us to dedicate more resources to things like vMotion, ensuring that they get the resources that they need and can be successful with things like long-distance vMotion. Speaking of long-distance vMotion, yes, not only is cross vCenter LAN-based migrations enabled, but also WAN-based migrations are available for us. Lots of different use cases for long-distance vMotion, including your hybrid data centers, which will allow us to migrate from our private data center into the public cloud, where they're using ESXi hosts in the public cloud. I can just migrate my workloads from source to destination, right? If I want to move my data centers, if I want to do multi-site load balancing, if I want to do disaster avoidance, moving all of my virtual machines from one data center to another data center that's out of harm's way of a natural disaster, for example, okay? Lots of different use cases for long-distance vMotion. Prerequisites for long-distance vMotion. For the virtual machines, when they land on the destination host, they should not have to change their IP address. That is a layer 2 connection for the VMs. For the vMotion network, we can actually do layer 3, okay? If you are not using vSphere 6.5 or later, and you're back on vSphere 6.0, you might want to separately secure the WAN link, because we will not encrypt the vMotion. Anything later than vSphere 6.5, all vMotions will be encrypted, and at least you know that your memory footprint on that WAN link is protected. We need 250 megabits of bandwidth per simultaneous vMotion, and the round trip time for latency between the source and the destination sites must be within 150 milliseconds. Okay, finally we get to our vMotion lab, and we're going to do the whole stack from start to bottom. We're going to build VM kernel ports on each of 2 ESXi hosts. Make sure that you don't configure the same IP address on both hosts, okay, for your VM kernel ports. That's the first 2 tasks. Then we're going to do a vMotion, okay, by preparing the virtual machines, making sure that it doesn't have a local ISO image attached, and so on. And finally, in task number 4, you'll execute the vMotion. Have fun with this. I hope you enjoy. And that does it for our lesson, our first lesson on vMotion itself. We've got some language now around how we label these types of migrations. Is it a hot migration that we call vMotion? Is it a cold migration? Is it a suspended migration, which we lump in with the cold migrations and so on? We know the architecture of vMotions, and we know all the requirements of vMotions, and we now know how to prepare our ESXi hosts to enable vMotion. Okay? When we come back, we're going to have a look at enhanced vMotion compatibility to ensure that even when our ESXi hosts don't have exactly identical CPUs, that we can still perform vMotions from host to host. We'll talk to you real soon.